Welcome everyone to part 2 of simplifying radicals. In part 1, we kind of gave an intro of what is a radical, and then we talked about the first condition is, which was there are no perfect squares when you simplify a radical. So you have to get rid of all the perfect squares. And now condition 2 is you can't have a fraction underneath the radical. So what do we do? Okay, so here's our first example. We have 54 divided by 3. And the square root of that whole thing. Now, when it's divisible, evenly divisible, what you really should do is just do 54 divided by 3, which you can simplify that. 54 is evenly divisible by 3, and that is 18. So then we can essentially rewrite this as, I want to redo that. We can rewrite this as the square root of 18. Now, from here, we see that we have condition 1, which means we have a perfect square within this radical. So what we're going to do is we're going to simplify this further. A couple different ways we talked about. If you're not sure if there's a perfect square that goes into it, what you can do is you can always factor. So in this case, it's 2, 9, 3, 3. Anywhere we see 2 of the same radical, we know that one of those numbers is going to come out. Okay, in order to leave the house, you have to have a date. So you get 1, 3 comes out, and then this 2 gets boxed because he has to stay home. He doesn't have a date. So he stays home, and there you go. 3 radical 2 is going to be answered there. Now, let's say you do recognize that this is the multiplication of 2 times 9, and you recognize that 9 is already a perfect square. Well, then you can rewrite this as square root of 9 times radical 2, and then you get 3 radical 2 for your answer. Same thing, okay? 2 different ways to do that. I think that's the most popular way. Now, there's another way to consider radicals. Let's say you are looking inside this radical and you see the fraction and it's like, okay, 16 divided by 9, that is not evenly divisible. I can't reduce that. 16 and 9 don't share any factors. What do I do? Well, you can always rewrite this as the square root of 16 over the square root of 9. That's the cool thing about radicals. You can rewrite them like that. So now this simply becomes 4 over 3, and that's going to be your final answer. So you can always separate the radicals to have, the fractions to have a radical on the top and then a radical on the bottom, kind of split up the radical that way. And lastly, we have square root of 100 divided by 4. You can do this 2 ways. One, and this is just to show why it works. One, we can divide. 100 divided by 4 is 25, so we can rewrite this as a square root of 25. Or we can write it as a square root of 100 over the square root of 4. Let's see what we get. Well, we know the square root of 5 is going to give us 5. Okay, what's this going to give us? Square root of 100 is 10. Square root of 4 is 2. So this becomes 10 over 2. This becomes 5. Notice how we get the same thing even when we split it up into 2 different methods. Okay, so that's just to show you how it works. You can use either one in this particular case, but in some cases you'll have to use one versus the other. Lastly, we're going to talk about condition 3. Condition 3 is when we have a radical in the denominator, okay? So a radical in the denominator that we can't solve. So let's go ahead and first get into some lead-up questions. Now, if we have the square root of 4 times the square root of 4, this we could rewrite as the square root of 16, and we know this, of course, to be 4. Okay. Another way to think of this is we could say the square root of 4 times itself twice is the same thing as square root of 4 squared. Squaring undoes square root, so this is going to be 4. Another way to just think of it is, okay, I got 2 square roots multiplied by each other. It essentially undoes the square root, and I get 4. Okay, I get what is under the square root when I multiply it twice. Okay, so if we're looking at this one, I see, okay, square root of 5. Square root of 5, I'm multiplying it twice. I am just going to get 5, what's underneath the square root. But if you're not comfortable with that, square root of 5. Okay, that's another way to do it. But I highly recommend, just for recognition purposes, that you recognize that you can, in fact, multiply 2 square roots together of the same number, and you're just going to get what's underneath the radical. The radical disappears. How can we apply it to this one? Well, first we can see that we can take the square root of 4, and that's going to be 2. But the square root of 3 is nagging us right in the bottom there because we can't get rid of it. How do you suppose we get rid of it? Well, one of the conditions is a denominator does not contain a radical. Well, this goes against that rule, so what do we do? Well, if you saw earlier with these problems, we can get rid of a radical if we multiply the radical times itself. So what can we do here? Well, if we could just multiply this square root of 3 times radical 3, we would get rid of it. Okay? But here's the thing. We can't just multiply by radical 3, okay, to this problem, because that changes the value of the problem. So we're kind of stuck here. Well, we're not stuck. I'm going to move this guy over because we're going to use him. Because technically what we can do is we can multiply this by 1, and we're still going to get 2 radical 3. Okay, 2 radical 3. It doesn't change the value when you multiply by 1. What am I leading to? And what am I getting at? Well, if I put this radical 3 over here, okay, but what I do instead is I go radical 3 over radical 3. Now this value becomes equal to 1. It's essentially multiplying by 1. So what I'm doing now is I'm changing the look of the expression, but I'm not changing the value of the expression. If you just multiply by 1, I'm not changing the value. I'm just changing how it looks, okay? Square root of 3 divided by square root of 3 equals 1, in case you weren't following that. 5 divided by 5 is 1. 12 divided by 12 is 1. Anything divided by itself is 1, and you can multiply it by the top and bottom, and you're fine. It's just like simplifying fractions. Okay, so let's see what that does. Well, the whole point was to get rid of this radical in the bottom, so we get radical 3 times radical 3. You could do like that's equal to radical 9, or you just recognize that it undoes the radical, and we get 3 in the bottom. Then in the top, what do we get? We get 2 radical 3, okay? And this is our final answer, 2 radical 3 over 3, or if you want 2/3 radical 3, but that's kind of ugly. I don't prefer that. I would just write it as 2 radical 3 over 3. Now this follows all the conditions. There's no perfect squares inside the radical. There's no fractions inside the radical, and there's no radical in the denominator. All 3 conditions are met, and there is our final answer. Whereas, let's go ahead and apply this. Now, 2 different ways to do this one. One, you could take the square root of 144, and that's 12. And then we have radical 2 in the denominator, and then we multiply by radical 2 over radical 2. Okay, anytime you have a denominator of radical 2, in order to get rid of it, you multiply it top and bottom. Okay, so then we get 12 radical 2 over 2. We can reduce. Okay, that's our final step, reduce. 12 divided by 2 is 6, and that's 1. 6 radical 2 over 1, or just 6 radical 2 for our final answer there. Now, another way to do this problem is to recognize that square root of 144 is the same thing as the square root of 72. 144 divided by 2 is 72. And then what we can do is we can simplify this one. So that's 2 and 36. Okay, so I recognize that 36 is a perfect square. So he's going to come out. This guy's going to stay in the house. The square root of 2. And then the square root of 36 is this guy, okay, which becomes just 6 radical 2. It's the same thing we got over here. Okay, so two different ways to do that problem. Square root of 36 over square root of 3. Okay, 2 different ways to do this one as well. So let's go ahead and show you the first way, which is multiply by radical 3 over radical 3. How do I know to do that? It's because I see radical 3 in the denominator. I want to multiply by 1, but I want to change the look. So I'll make it radical 3 over radical 3. Okay, now this is kind of the tough part. Well, I guess first I should turn this to a 6. So I have 6 radical 3 in the top. I have 3 in the bottom. I'm going to cancel here. That gives me 2 radical 3 because 6 divided by 3 is 2, and that's my final answer. Okay, now square root of 36 divided by 3. This is another way to do this problem. I said there was going to be 2 ways. So I could rewrite this as, what I want to do is, let me change color. Make it a little bit more clear. So this essentially could be rewritten as square root of 36 over 3. If you can separate it into top and bottom radicals, you can also combine it underneath the same radical. So that gives us square root of 12. And then we can go about solving square root of 12. So I factor tree 2, 3. I have a pair of 2s, so 1 is going to come out of the house. The 3 is going to stay home, doesn't have a date. And there I have my answer. 2 radical 3, it's the same thing. Okay, here we go. We got a lot this time for example 6, and this is our last problem. Well, first we should recognize that square root of 9 could be simplified. So the easiest way to do this would be square root of 18, multiply the 2 in the top, over 3. And then I just simplify the top, which is, I know this is the same thing as square root of 9 times the square root of 2 over 3. So then I get 3 radical 2 over 3, cancel, equals radical 2. Okay, that's probably the quickest way to do it, but let's say you didn't see that. How could we do this problem? Well, you might want to still multiply radical 6 times radical 3 in the top, get radical 18, and then over radical 9. Okay, now let me show quick tangent. We could also do this. Radical 18 over 9, that's radical 2, and you're done. That's it. 18 divided by 9 is 2. Okay, that's another way to do it. But let's say we didn't do that way. And what instead we're going to do is multiply by radical 9 to the top and radical 9 in the bottom. That would give us 9 in the bottom, and then we'd have 18 times 9 in the top. Now, you could also simplify. What I like about these is there's so many different ways to do this problem. Think about it. We could simplify square root of 18 first, and square root of 18 reduces to 3 radical 2. We kind of already showed that there. So we could write 3 radical 2 times square root of 9 in the top. Okay, so then we'd get 3 radical 18 over 9, and then we already know that square root of 18 reduces to 3 radical 2. Okay, we already said that. So this is going to become equal to 3 times 3 radical 2, because that's the same thing as radical 18, over 9. This goes to, sorry, I need more room. And you're probably like, why are you doing this? I'm just showing you that there's so many different ways to manipulate this. And sometimes you'll need to use these ways, but other times you won't. So square root of 2. So we get the same answer in 3 different ways. So there's tons of different ways. These are like building blocks. You can play around with them. Another way to do this, I'm going to show you real quick. Okay, let's use the first way where we just put the 3 in the bottom. So radical 6 times radical 3. We already know that's 3 in the bottom. Square root of 9 is 3. We can simplify the top to be radical 3 times radical 2, because that's equal to, let me change the color. Radical 6 is the same thing as radical 3 times radical 2. 3 times 2 is 6. So times radical 3 over 3. Well, I know that radical 3 times radical 3 equals 3. So I can write 3 radical 2 over 3, and then I cancel, and I get radical 2. So that's 4 ways to do that problem. You're welcome. But I hope you enjoyed this video. If you need any more help with these types of problems, let me know. There's going to be a video in the future on adding and subtracting radicals, so stay tuned for that. Anyway, thanks for watching. I hope to see you next time.